When we picture our solar system, it is easy to imagine a random scattering of rocks floating aimlessly through an endless, chaotic void. But the reality is far more structured. About 4.5 billion years ago, a massive cloud of interstellar gas and dust collapsed in on itself, forging an organized gravitational machine. This diagram shows exactly how that material settled. The Sun swallowed 99.8% of all available matter, leaving behind a tiny sliver that accounts for every planet, moon, and asteroid in our neighborhood. How did the Sun's immense gravitational pull organize that leftover fraction into distinct architectural zones? And how far out do you have to travel before that gravitational grip finally lets go? Mapping these boundaries reveals the rigid physical laws that dictate our cosmic neighborhood, showing us why specific worlds formed exactly where they did. The engine driving the entire machine is the Sun. It generates constant power through nuclear fusion, compressing hydrogen atoms into helium at its core. This volatile outward energy dictates the conditions of the closest planetary zone. In this region, only materials that can withstand intense solar heat are able to survive. We call this first zone the inner sanctum. It contains the terrestrial planets, Mercury, Venus, Earth, and Mars. Because of their proximity to the solar engine, light gases and ice boiled away during formation, leaving behind dense, solid rock. Venus represents the extreme edge of this environment. It rotates on its axis backward compared to its neighbors, and its thick carbon dioxide atmosphere traps solar heat, baking the volcanic surface at a blistering 867 degrees Fahrenheit. Right next door, Earth sits at a specific distance that allows for liquid water systems. This placement created the only environment we know of capable of sustaining life. The final terrestrial world is Mars. While it is a desert today, its rocky surface and atmosphere supported a moist, watery environment about 3.7 billion years ago. The defining rule of this inner sanctum is durability. These worlds are defined by small-scale, solid surfaces and the survival of heavy elements under intense solar heat. Beyond the rocky planets lies our first major architectural boundary, the asteroid belt. This flat disk of debris acts as the rebel left over from the initial formation of the solar system. The largest object in this rocky boundary is the dwarf planet Ceres. Though it sits among millions of smaller fragments, Ceres has enough mass to pull itself into a distinct spherical shape. Crossing this boundary leads to the Jovian realm. Here, temperatures drop low enough for planets to accumulate massive layers of hydrogen and helium gas, rather than solid rock. Jupiter sits at the start of this zone. As the largest planet in the system, its chaotic atmosphere of swirling gas bands holds more mass than all other planets combined. Nearby is Saturn, defined by its expansive ring system. While these rings of ice and dust are wide enough to fill the gap between Earth and the Moon, they are barely a kilometer thick. Further out are the ice giants, Uranus and Neptune. These worlds are composed of rock, ice, methane, and ammonia, with Neptune serving as the outermost major planet in the system. The Jovian zone stands in total contrast to the inner planets. These are immense worlds defined by a lack of solid surfaces and complex systems of rings and moons. Past Neptune, we enter the second major boundary, the Kuiper belt. This massive ring of frozen debris is significantly larger and wider than the inner asteroid belt. This frozen frontier is the birthplace of many comets and home to a distinct class of objects that never grew large enough to become full-fledged planets. Pluto is the most famous world in this region. Its surface features nitrogen glaciers and mountains of water ice, showing that even these distant, frozen worlds have complex geographies. Pluto's status changed in 2006 when the IAU established a new rule. A true planet must have the gravitational power to clear its orbital neighborhood. Because Pluto sits within the crowded debris of the Kuiper belt, it was reclassified as a dwarf planet. This clarifies exactly what the Kuiper belt represents: a crowded, dynamic zone of leftover planetary building blocks, all bound by the Sun's strict gravitational influence. Moving far beyond the planets brings us to the Oort Cloud. This diagram shows a vast spherical shell of icy debris encapsulating our solar system. This immense cloud is the true physical border, the exact point where the Sun's gravitational influence finally ends. Seeing the scale of this outer architecture makes the solid inner worlds where we began feel incredibly small. Earth sits at a precise point within this multi-tiered machine. Sheltered by the gas giants and warmed by a stable star, our world is a product of this specific gravitational balance. By understanding this beautifully ordered gravitational masterpiece, we reveal why our small, watery world is such a rare haven in the dark.